So this example just reviews some basic terminology describing circuits, as well as the basic interconnections which may be realized between elements in a circuit. I'm using the definitions which are followed by Alexander in his introductory text for this. We're asked to find the number of branches, nodes, and loops. Branches, by definition, pretty common, just any component through which current can flow. Therefore, in order to identify the number of branches, simply count the number of unique components. Which, of course, in this case would be 4. Sorry. For the next part of that problem, we're asked to identify how many nodes are present in the circuit. And a node, by definition, is just a point of connection between two or more elements. So you'll notice between the positive terminal of V1 and one of the two terminals of R1, we have a node right here. In addition, between the other terminal of the 5 ohm resistor, one terminal of the 6 ohm resistor, and the outflow terminal of the 2 amp source, we have an additional node. So this is different than that, as it involves the connection of 3 elements. As you recall from the circuit theorems, which we'll discuss shortly, you may refer to that as a critical node. In addition, we have a common point of connection between the resistor, the inflow of the current source, and the negative terminal of the voltage source. This is all one together, even though it's separated in space. So in short, we have 1, 2, 3 nodes. So 3 nodes. In terms of a loop, remember that a loop is just any closed path in a circuit. If you're familiar with the circuit theorems or the circuit analysis techniques, you may remember employing mesh current theory, and from that you count the number of loops. Clearly there are 2 loops in this circuit, or 2 complete closed paths. For part B, right, we're asked to identify any series or parallel connections between elements. Recall that a series connection between 2 elements shares one terminal, and therefore by definition there is the same current in both of the components. I'll use the reference designators here. Notice that the voltage source V1 and R1 share the common node 1 of connection, one terminal in common. And notice that they have the same current through them by definition. So I will say that V1 and R1 are in series, sharing one terminal of connection. And notice that R2 and the current source, the 2 amp current source, which I didn't label, I'll call it I. Here, I1. Those 2 share 2 terminals of connection. Therefore, by definition, they have the same voltage across them, and they are in parallel. So R2 and I1 are in parallel.